Oh, let me fix that real quick. All right, so I'm going to resume where we left off on Thursday. We got through one example on Thursday, and we got to do the other three. This shouldn't take too long since we did the bulk of it on the conceptual part of it we got done on Thursday. So today is the 16th. Oh, why am I using red? Don't do that. There we go. And this is more with end behavior, zeros, graphing, and this is just a CONT ... So this, again, we started all this on Thursday. So the next example that we have is this one. And when you get your assignment today, you'll just be, opening it up on Canvas, getting the problems, and then you'll be using your own paper. So when you sketch, you don't have to use graph paper. If you have any, it helps. But if you don't, you can just sketch for now on notebook paper. So our first example for today, second overall, is -2 x to the third plus 3x squared plus 9x. So the first thing we talked about, I know it's been a long time because I honestly, with Fridays off, it's I can say I haven't seen you in like 4 days. It's so crazy. So what was the first thing that we did when we looked at a function like this? Yeah, positive, negative, odd, even. Right. And so first off, if the exponent on the first term is odd, what does that tell us just in and of itself? If that's all we knew, what would that tell us? It's different. That's the key. Yep, that's the one word right there for your notes, is that the arms are going to do different things. So the graph's either going to start low and end high, or it's going to start high and end low. And if the term has a leading coefficient that is negative, then that seals the deal. What does that officially mean? High-low, right? And so this is just why notes are handy. Eventually, you won't need them anymore. You'll just memorize it if you haven't already, but this is a high-low. So we know when we go to make our graph that on the left side, it's going to end high going to the left, and it's going to end low going to the right. Always a good idea just to sketch that a little bit, just kind of ahead of time. So that's what we know generally the graph is going to do. What it's going to do in between, we're about to get a little bit more of a perspective on, but for now we know that much. So what's the next thing we do? I mean, if that's all we knew, we could not make a very good graph at all. Honestly, we would have very, very little to go on. So there's one other feature that really locks us in. Do you remember what it is? You have to find the zeros. Very good. And in order to find the zeros, what you do is you take the business end of the function and you quite literally set it equal to 0. If you can take a graph and set it, if you could take a function and set it equal to 0, then you're manually forcing the math gods to tell you where it crosses the y-axis. Excuse me, where it crosses the x-axis. What I meant to say is you're manually finding the places where y equals 0. And for y to equal 0, you have to be on the x-axis. Like that's a definition, huh? Okay, so now we flex the quiz that we just took last week now comes in handy, and we factor. So tell me about factoring this thing. What do we do?
Find the GCF.
For sure. And what is the GCF? Negative x. The 2, the 3, and the 9 don't provide anything in common, but there is a negative in the front that we know to pull out, and they all have at least one x. So we're going to pull negative, we're going to pull x, and then we're going to rebuild. And what is the new function going to be, or the new polynomial, I guess? Nice. Okay, and then what winds up happening now is our focus goes from being that long red problem to just this purple problem. Because once you know this, because it's all we did for the first 3 weeks, once you pull out a GCF, then you focus on what's left. So what kind of polynomial is that, the purple one? It's the one that I think is hardest for you guys to answer because it's just something that I think yeah, it's just a quadratic. You're so intimately familiar with these, not only from the end of Algebra 1, but because you see them a lot. Quadratics are really huge. We do an entire unit in this class just on quadratics. Just quadratics, nothing else. So that'll be soon-ish. Anyways, for now, we know to factor this, we need to build 2x squared. So we're going to make a 2x and a 1x like this. What are my signs going to be? For sure, a positive and a negative. I know that they're going to be 3s because they got to make 9. And then it's just a matter of balance at this point. We want to make sure that when we do our double multiply add thing to check, because that's how we always check quadratics, we want to make sure that it comes out to be a negative, just like this yellow thing says. That's the key. You want to make yellow, make it happen. So you want to put the minus on the bigger one, the 6x, and the plus on the weaker one, the 3x. Just factoring 101 right there. Do you guys know how, I don't think I've asked you this question. How many factors do you see? And I know that's on me because I don't talk in these terms a lot. The factors are the pieces that we've broken something down into. So each multiplicative piece is called a factor. How many of them do you see? I see 3. This is called a factor. Red guy. This is called a factor. Purple guy. And this is called a factor. Green guy. So we're at the stage now in the problem where our goal is to say, well, if you 3 factors together multiply to equal 0, which is clearly what this says over here, then at least one of you has to equal 0. That's the only way in math to have things multiply to make 0. Let's start with red guy. What makes red guy equal 0? What could you put in place of x to just make the red thing equal 0? Nope. I might have heard it. It's a number. It's 0. If x equals 0, if you could change x into any number, the only way to make the red circle literally become a 0 is with the number 0. If you try to put a 1 or anything like that in there, it's going to equal -1 or 4 or something like that. If you want to make it 0, make it equal 0. So anytime you have a GCF with a variable like that, one of your answers, one of your zeros is always going to be the number 0. Okay. How about the purple guy? Close. Very perfect. Yes. Remember, we always have to, and I'll show you this off to the side. We always have to make the factors equal 0. And this just goes back to like 8th grade, right? Solving a little purple equation like that one over on the right side you see. How would you solve that? You'd subtract 3 from both sides first to get this, and then what would you do? Right. And the reason I'm showing you this is twofold. Number one, I want you to understand where these answers come from. But number two, when, not if, but when you forget how to make the factors equal 0, you can always empower yourself. Go off to the side, set it quite literally equal to 0, solve it. And then you'll never wonder like, oh, how do I do this again? Just make it equal 0. You don't need to show this work. That's just for you. I mean, whatever. Having said that, how do we make the green one equal 0? Just a 3. Yeah, just if you said x minus 3, I need you to equal 0, then you'd add 3 to both sides and presto, done. So what we do now is, remember, we put all the pieces together and we make a sketch. It's not perfect, okay? There will come a point at someday, a class after this, where we can go into even more detail as to how to find specific highs and specific lows. But we have a lot of information right now. So we want to make a sketch of our axes. So we want an x-axis. And again, you'll just do this on your paper when you get your homework. And the first thing you're going to do is mark your zeros. And so the red 0 is literally at 0. Do not confuse the word zero with the number 0. A 0 as a noun is a location where a graph crosses the x-axis, not to be confused with the number 0. Okay, so that has a 0 at 0. Go figure. Where's the purple 0 going to be? No, it's not a slope. Here, oh, geez, holy fat pen, Batman. I'll make some little marks for us. So let's do like -1, -2, -3. If you're using graph paper, it's easier, but if you don't have graph paper, that's okay. You can just mark your own scale. What does this purple thing even mean? What is -3/2? Like, what does that even mean? It's a good time to think of it as a mixed number or as a decimal. What is -3/2? It's -1 and 1/2. So we're going to go left 1 and 1/2 and make our first mark there. Second mark. And what about the green one? Where's he at? Right, 3. 1, 2, 3. So there's that in and of itself is not enough information. And again, I know it's been a while, so I'm going to say this again. If someone told me that I had a third degree function that goes through those points, I would be able to say that maybe it goes like this, or maybe it goes like this. And who saves the day?
That one.
Who saves the day? Why do we know? Who tells us?
Found the negative.
The end behavior, right? And that's the first thing we talked about in this problem. It was the first discussion we had. We already knew, because we sketched it earlier, that the graph is high-low. So if we know because of the end behavior that it starts high and ends low, then we've solved our mystery. We know it goes through this way. We know it goes through this way, and we know it ends this way. So if you put those pieces together, you can get a pretty good sketch of the graph. That's a lot of information coming in quite handy. And then you just connect it and try to make it a decently looking smooth curve. And presto. How high is this point? That's not our concern right now. How low is this point? That's not our concern. Okay, we're just making do with what we have right now. That was the goal for these few days, is just, can we find zeros with end behavior and make sketches based off of that? Good. Okay, let's do another one. Your next example is f of x equals 3x squared plus 8x plus 5. Step 1.
Would be positive, and you're going to have to look at the degree.
Yeah, so again, the combination of this being an even number and this being a positive will tell us everything we need to know. What does the evenness of the two tell us? It's either high, high, or low, low. We just know that the arms will behave the same. Then if we look at the red, you've seen this with factoring, where we look at one number, but then we defer to another number to get more info. So the 2 tells us they either both go up or they both go down. The 3 then steps in and says that they're high and high. So we know going into it that the graph is going to end high on both sides. Okay. Because it's a second degree function, this will not have any twists and turns. This will be what we call it's a P word. You guys know what it's called? The graph of a quadratic starts with a P. It's called a parabola. So these ones are actually a parabola. P-A-R-A. Oh, snap. I keep forgetting to. P-A-R-A-B-O-L-A. A parabola. Okay. Those other ones were called, those are cubics. And when you graph them, they have that more snaky look to them. They kind of snake up, down, and back up, or down, up, and back down. So next step, bless you. Good job. And there is not one, but it warms my heart to hear you say that. So if we have 3x squared plus 8x plus 5, and we set it equal to 0, yes, exactly, Mari. We always want to look for the GCF. There isn't one here. So we can proceed to the next step, which is just a factor. And because it's a quadratic, this one's going to factor, I think, pretty quickly into just a pair of shells. What do we know goes in the shells? What are my signs?
Negative and negative.
Definitely positive and positive, because they have to add to make a positive, right? It could have been negative, negative if it weren't for that 8, right? And then we know it's a 5 and a 1. And putting the 5 across from the 3 would be dumb, because that's going to give you 15. So you want to kind of neuter the 5 by putting it there, weaken it like that. And then you get your perfect 5x, whoop, 3x, whoop, to make 8x. And then, of course, it's time to find the zeros. What zero do we get from the red guy? What makes that red oval equal 0? Perfection.
One, two, three, four.
Good. Mhm. And then what about the purple one? Good. So what we want to do now is go to our axes and mark them. And like Mari said, you want to understand what mixed numbers and improper fractions and decimals, how they all mean the same thing. Sometimes decimals are good. You've hung out with me long enough to know how I feel generally about the use of decimals, but there is a time, right, where this is good to know that what this is. It's like negative 1.6 repeating, or negative 1.7, or negative 1 2/3. What it just come to some context on that. So we're going to go to negative 1 2/3 of the way to 3, whoop, and make our 0. And then we're going to, for the purple guy, go to negative 1. Boop. Now, yes, ma'am.
With grabbing the ones that are all the same, do they not have 3 to 5?
Sometimes that's a really, really, really good question. If they do have a GCF, it's you won't see it today. There might be a numerical GCF, like you might be able to pull out like a 2 or a 3, which winds up not having any impact, just for the record. But if it did have a GCF of like X, then it wouldn't be a parabola. It would have had to have been like a cubic or something.
Okay, so.
Let me say this. I don't mean to cut you off, but I'm going to. Let me say this. When you look at the beginning of a problem, if you're listening carefully, this will help you. Look at what I'm going to circle in green. That's a degree of 3, right? That means that it will have 3 zeros. It'll cross the x-axis 3 times. So that tells you right away the characteristic look of that graph is going to be a cross, 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 right? Did we factor a quadratic? Yes, that was part of the process. That thing I'm vandalizing in green, what the function itself was not a quadratic. So, does that make sense, Kyle? Kyle, does that make sense? Okay. And so you see those are cinched pretty tightly together, and we know that the end behavior is up, up. So we know it's going to go up like this, and we know it's going to go up like this. And then the hard part is just trying to make the graph not completely suck like that. So I hope you've gotten the idea. We have one more example, but I think by now you've got it. Like, find the end behavior to describe the general behavior of the graph to get a visual, and then find the zeros to zoom in and find the actual crossers. All of today's problems on assignment number 7, I think it is, maybe, they're all going to be either parabolas or cubics, just FYI for now. We'll up that here in coming days, like tomorrow. All right, our last, what was it called? That's a cubic. Yep.
The parabola is just one where it's like 4 to the side.
Yeah, so like a cubic, so 3rd degree will generally behave either like this or like this, and then a 2nd degree will be either like this or like this. Does that help? Okay. You're welcome. All right, let's do one more real quick. When I wrote these examples, I just wanted to make sure that I did an example of every type that you're going to see in your assignment. So can you tell me right away what this is going to look like? You don't have to be specific. What kind of a graph is it going to be? Oh, that was quite specific. Yeah, it's a parabola, right? Good. But good for you. That you're learning, and that's good. So it is a low parabola. The 2 tells us that the arms behave the same. The -5 in front tells us that that sameness quite specifically is down and down. So going into it, we know the graph is going to look like one of these, a parabola, right? Good. So the only thing left to do is figure out, where does this little Yahoo cross the x-axis so that we can zoom in on it. So let's take our polynomial. And this goes back to a question that Kyla had a few minutes ago that I think did a pretty poor job of answering. Does this have a GCF? It does. It's just, again, not a GCF that has a letter with it, because I look at it and I can't pull X out of all of them or anything like that, but it is just negative or -1. And we remember, we always pull negatives out of things when we're factoring, because that saves us the headache of having to try to factor things with an extra negative. Things can be factored, FYI, without, but it's bad practice. So don't do that. So we're going to pull the negative out, but just get it out of the way. And we're going to be left with 5x squared minus 2x minus 3. And now our focus is factoring just the purple thing, right? Okay, so tell me about that. If I went to factor it, what would it look like? What are my signs? Plus and a minus. Good. And I think we want to do a 3 here and a 1 here, minus on the strong 5x, plus on the weak 3x. Now, how many factors do you see? There are 3, but I'm here to tell you that this one, let me circle it in yellow. This one produces nothing. Why?
Outside of it.
Because it has, yeah, it has no variable. Something can't produce a 0 if it's just a number. And again, this goes back to that very well-timed question from 5 minutes ago. Does it have a GCF? Yes. Does it produce a 0? No. So if you pull out a negative or a 2 or a 3 or a negative, whatever, if it's just a number, it produces no fruit. Is it a throwaway? In this case, effectively, yes, we don't need it. Okay. Now, let's take a look at our factors themselves. What makes Mr. Green equal 0? -3/5. What makes Mr. Red equal 0? +1. And then it should all come together at this point. We know if all we knew were the green and the red, then it would be ambiguous. We wouldn't know what to do, but the end behavior locks us in. So we're going to sketch our x-axis and our y-axis. And we're going to make some marks. I would think that we could do just like maybe a couple on each axis, something like that. -1, -2, 1, 2, right? You're sketching this yourself, so you're in full control of what you want your axes to look like. And then we're going to make marks. So where's Mr. Green going to be? How do you describe -3/5? Like, where do I go? To the left, 3/5 of the way to -1. And 3/5 proportionally is more than a half. So, yeah, mark it like that. Where is the red guy? To the right one. And using what we said earlier about the end behavior, we know that the end behavior on this one was down. So that should be enough then to make a sketch. We know it comes up through here. And who knows how tall it goes. We'll get into that when we do our full unit on quadratics. Okay, but that's what that looks like. So, any questions? All right, your assignment will be on Canvas. I just need to quick publish my Canvas page, but it'll be on there. I'll just pause this in case you have any questions, but let me get that published real quick.